Alright, in this video, I'm going to walk you through exactly how I built the Noaa Satellite Mission Command Center demo from the ground up. Now, if you haven't seen part 1, go check that out first. That's where I show the live demo in action with real telemetry flowing. This is where AI agents are reasoning through events and the platform is making autonomous decisions in real time. This video is going to provide you some guidelines about how it was built, step by step. So if you want to follow along or even build something yourself, I'm going to include everything you need down in the description field. You're going to find a link to part 1, the demo itself, a collection of about 30 of the most useful build agent prompts that I use to build the platform and the UI. I'll include my demo cleanup script, a step-by-step build summary that you can follow along to develop a framework of your own, and the AI agent design reference. This is going to be complete with full agent configurations. Everything's there, the same assets I use to build and document this project so that you can learn from it or use it to design your own demo. Now, how did this all start? Well, it started as an idea. Could we build a ServiceNow dashboard that feels like a NASA command console that not only monitors the data, but reasons about it? So I partnered with my good friends ChatGPT and Gemini, I'll call them my AI assistants, to kind of shape the concept. And we mapped out a realistic space ops workflow inside of ServiceNow and broke it into modules. First, the telemetry ingestion, then the anomaly detection. Then we looked at AI reasoning. Then we moved on to human review. And finally, automated summarization. Using the build agent, I created the core data model. This comprised of 3 custom tables that everything else connects to. We had the satellite event. This is going to be for raw telemetry events. Then we had this space mission review queue. This was for ambiguous events that needed human input. And then finally, the mission summary or executive level summaries. Now, because this bridges mission ops to potentially IT ops, we tied this directly into the change request table in the ITSM module, so the system can create and populate real changes. Now, to show reasoning, we needed believable data. So again, I went to my trusty AI assistants to generate mock telemetry data as JSON, covering signals like subsystem, metric, value, status, severity, and even confidence. So each record simulates how an operations team might monitor telemetry with realistic values and thresholds that help agents make contextual decisions. I started with goes 17, 18, and 19. Once that data looked realistic, I wrapped it into a JSON array and uploaded it to a GitHub repository. With Build Agent, I prompted create an import process that reads this JSON from GitHub and writes it into the satellite event table. Build Agent then produced the REST message, the connection, and a background script to parse and insert each JSON object. Now, to simulate a stream, I added a scheduled script execution job to run the import on demand, or of course at an interval if that's what you desire. Now, originally I considered the flow designer, but I moved the trigger directly into the agentic workflow of the mission anomaly agent. Now, ingestion and reasoning all happens with one autonomous path. Now, if you're going to rebuild something like this, I would suggest to make the GitHub JSON accessible publicly, and then, of course, match the field names to your schema. You want to include at least one metric that crosses a threshold so that the agent has something to make a decision about. Now, with data flowing, I built the Mission Command Center dashboard as a custom React experience under ServiceNow's UI framework. And it really used React and CSS together. Then I asked the build agent to create a dark mode React dashboard under the ServiceNow UI with 3 tiles, one for each GOES satellite, each of them showing their live telemetry status. Then build agent produced the base React component with layout containers in color state logic. So each tile displays a status from the satellite event table using mission ops conventions. So for example, green was normal, yellow was warning, and red meant that there was some sort of anomaly to look at. Then of course I had the build agent fine-tune the layout, adjusting things like padding, centering the headers, evenly spacing the tiles, fixing alignment, and making the interface mobile responsive. The result was a clean, dark mode console that highlights status changes and stays balanced on any screen size. Now again, if you're going to build your own UI experience, use Build Agent for scaffolding and refinement. Keep your refresh logic simple and predictable, and then of course prioritize spacing, hierarchy, and responsiveness. Just using those words alone within the Build Agent structure will allow you to prompt it to build you what you're looking for. Now let's talk about triggering the agentic workflow itself. The trigger lives inside of the Mission Anomaly Agent's workflow. When a new record is written to the satellite event table, either from GitHub or from a scheduled job, the agent runs its steps. Number 1, it looks up triggered events, identifying that incoming record. Number 2, it's going to gather that data, things like the metric, subsystem, value, etc. Then it's going to reference the knowledge base, retrieving relevant information about policies and thresholds. And finally, it's going to go through the compare system, where it classifies as normal, anomaly, or warning. Now, if the thresholds are clearly violated, it's going to create a change request, submitting that to the proper team. If the data is ambiguous, it's going to create a record in the Space Mission Review queue for a human to analyze. Now, everything here is self-contained in the agent, which keeps the design clean and reusable. Now let's talk about how the AI agent does its reasoning. Each run of the AI agent produces an execution plan that records the agent's objective and sequence of steps. Now within that plan, each tool invocation, like looking up a triggered event or creating a change, is logged with inputs and outputs. Now you can inspect all of this inside of the AI agent workspace, which shows how the agent reached its conclusion. That built-in transparency is what makes the reasoning explainable during demos. You can open the execution plan, you can expand the tool runs, view the results, and then jump straight to the records that were created. But to keep your demo running smooth and not having to constantly go back to the AI Agent Studio, you can build this right into your React screens. So let's talk about exactly what the Mission Anomaly Agent does based on its configured steps. Number 1, it detects and retrieves. So 1, it looks up the triggered events to find those telemetry records that activated it. It collects things like the metric, value, subsystem, and any other metrics that are important. Number 2, it's going to reference the operational knowledge. It retrieves telemetry and thermal operations policies from the knowledge base, compares that incoming data to those thresholds and guidelines. Then it's going to analyze and summarize, assessing the severity. It's going to decide if it's clear or ambiguous. If it's ambiguous, it's going to record the case in a mission review queue as a new record with all that relevant context. Number 4, it's going to use confirmation. It's going to communicate the action being taken whether it's creating a change or logging it for review back to the user. Number 5, it's going to record creation. So if a clear threshold criteria is met, it's going to create a change request and populate those fields like short description, justification, assignment group, and so on. If it's ambiguous, it's going to create the review queue record with the event ID, the subsystem that's affected, and it's going to assign it to the right team, whether that be power or thermal. And finally, it's going to provide a confirmation summary. It will display a complete message summarizing the decision, the record type created, and the rationale. Now, every time you finish a demo, normally you want to clean out those records that were created and reset your environment. So I've included a demo cleanup script. This is a one-time cleanup script that removes the satellite events, the change requests, any execution plans that were created, all of the space mission review queue records, and the mission summary records. It also includes what's called a dry run flag and a summary of the logging so that I can preview the changes before running it live. For daily situational awareness, there's a separate periodic mission summary agent that runs a telemetry search and gathers recent events, plus any change requests and review escalations. It aggregates the situation, key signals, and recommendations, and it's formatted in sort of a GitHub flavored markdown. It displays the summary and writes it to the mission summary table with the current date. This provides an exec-friendly, repeatable mission briefing for leadership to review. At this point, the Mission Command Center becomes a reusable foundation for any mission-driven scenario, not just for Noaa. Finally, I want to talk about some lessons learned. Here are a few of the lessons that made a huge difference. Start with your data model. Keep your JSON fields consistent with your table schema. Next, keep your build agent prompts modular, meaning tell it small sequential tasks to do to produce better outcomes. Next, use your AI Agent Studio for reasoning and orchestration, and then use the build agent for data and UI. Then finally, use execution plans in AI Agent Workspace for full reasoning transparency within your UI. All right, so that's the Noaa Satellite Mission Command Center from concept to completion, fully built inside of ServiceNow. Everything, again, is linked below. You've got over 30 build agent prompts that I use for platform and UI, a demo cleanup script, a step-by-step build summary, and the AI agent design reference, both complete with configurations. I hope this helps you build something that resonates with your customer's mission. Thanks for watching.